Right, so this question 95 is like question 94, and we're asked here at STP what volume of H2 is needed to react completely with 5.56 times 10 raised to the power 23 molecules of CO. Now, what we have to do is to convert these molecules of CO to moles of CO, okay, so that we can easily visualize it. So 1 mole of CO is equivalent to 6.022 times 10 raised to the power 23 molecules of CO, okay, according to Avogadro. Now, 5.56 times 10 raised to the power 23 molecules, that's molecules. How many moles is that? We'll get that by division there, so X would be 5.56 times 10 raised to the power 23 divided by 6.022 times 10 raised to the power 23. You see, a lot of students are scared at this point to compute this on the calculator. Sometimes when you're trying to compute this, you get an answer that you're not supposed to get. And maybe a tip that I usually give students, and I'm giving it to a lot of students, so this is it. When you type this on your calculator, this one here, when you finish typing it and you press the divided by sign, immediately after that, open a bracket, then type this, then close the bracket, okay? So that way you'll be able to get the correct answer. No worries, because a lot of people have done it, that's why I can tell you that we've seen that mistake a lot of time. 0.923, that's what you should get. So please try it. Yeah, pick up your calculator and try it to be sure. You don't want to make this kind of mistakes in the exam. So that's the number of moles of CO we're dealing with, 0.923. Now, at STP, what volume of H2 is needed to react completely with these moles? From the balanced equation, we can see that CO, 1 mole of it, actually reacts with 2 moles of H2, right? And it's balanced, right? It is. So that means if we had 0.923 moles of CO, it will just react with, let's call it Y this time around. And then Y would be 0.923 multiplied by 2. And that should give us 1.846 moles of H2. All right, is this making sense? Like this video at this point if it's making sense. We're not even done with it yet. This is just the moles of H2. We need to find the volume of H2 that should react with this amount at STP. And we already know that at STP, 1 mole of the H2 is equivalent to 22.4 liters. That's the volume of 1 mole of a gas at STP. So that means if I have 1.846 moles this time around, I should be able to know how many liters that would be, okay? And P will just be 1.846 multiplied by 22.4, and that should give me 41.36 liters, and that is our answer. I'll see you on 96. If you've watched like other videos apart from this very one, let me know. So that would mean that you're like a returning viewer. So that's really nice. It means that you're learning. So let me know so I can say hi to you in the comments. Bye.